We're going to be talking about the concept of molar mass of a molecule or an element, okay, and how to calculate the molar mass of something. So we will actually be using the average atomic mass of elements, okay? So way back in chapter 3, when we learned how to actually calculate the average atomic masses, this now becomes relevant and we actually use them now, okay? And we will use them for the duration of this semester, okay? So the idea of molar mass, okay, is that these numbers, maybe I can keep it off to the side here, okay? Your average atomic mass number, okay, that tells me the amount of grams of 1 mole of this element, okay? So your average atomic mass tells me the number of grams per 1 mole of your element, whatever element you're dealing with, okay? So if I said I want to find the average atomic mass of sodium, right? What is what is my molar mass? If I want to say what is my molar mass of sodium, okay, find it. All you do is you go to your periodic table, you find sodium, and it's 22.99. So your units are going to be, for molar mass of sodium, it's going to be 22.99 grams per mole. Okay, and no, I didn't spell it wrong. We like to abbreviate in chemistry, right? But you can't just abbreviate mole as a lowercase m, that's meter, okay? So we abbreviate it by just taking out the E, all right? So in case you're coming across stuff going like, dear God, why can't chemists spell anything correctly? No, MOL is just the abbreviation of MOLE. It saves us so much time to just not write one more letter, okay? All right, so it's gram per mole. You could see it written like this, gram per mole, or you could see it 22.999 grams per mole. You could see it either way, okay? It means the exact same thing, right? Moles on the denominator. All right, so that's relatively easy. You could do, same thing, like what is the molar mass of 1 hydrogen, of just H? And you're looking, and you bring it up to the camera so people can actually see, right? 1.01. So you have 1.01 grams per mole. What if you want to find the molar mass of hydrogen gas, which is H2, right? Hydrogen's one of your diatomics, so it's an H bonded to another H. It's 2 of them put together. It's a diatomic. Well, now I have 2 of them. So I'd have, 1.01 plus 1.01, which would be 2.02 grams per mole. All right, relatively easy-ish, okay? My puppy is chewing in the background. I hope that's not too distracting. Okay, what if you had to figure out the molar mass of NaCl? Okay, in this case, when you have 2 elements, you just add them both up. So sodium, right, 22.99, plus chlorine is 35.45. You add them together and you get 58.44 grams per mole, okay? Don't forget your units. Don't have naked numbers, okay? If you're asked for the molar mass of a compound or a molecule or an element, make sure you give your units in grams per mole, okay? Let's do something slightly harder. What if we had magnesium nitrate? Okay, now we actually need to break this down a little bit because you need to make sure that you do your distributive property with 2 nitrates, okay? So you can think of it this way, right? We have 1 magnesium, okay? So here we go. Your magnesium, it's right here, 24.31. Okay, then I have my nitrogen. Okay, nitrogen itself is 14.01. But there are going to be two of them, right? Because there's two nitrate groups. So now I want to say times 2, because there's 2 nitrogens. So this will be 28.02 for my 2 nitrogens. Okay, magnesium, there's only 1, so this is going to be still 24.31. Then for my oxygen, oxygen's a really nice one, 16.00. But this dude, I'm going to multiply by 6. There are 6 nitrogens here, right? 2 times 3 is 6. So I'm going to say, why can't I pick the same color here? Times 6. So that's what, 32, 64, 96. God, I hope my math is correct. Okay. Now I have all of the elements and as many of the elements that I have in this compound. And now I add all this up for my total molar mass of the compound.